All right, let's dive into something that could totally change how we think about AI memory. There's this paper from DeepSeek AI, and trust me, it's a bit of a mind bender. For the longest time, the thinking around AI memory has been super straightforward. You want the AI to know more stuff, you feed it more words. More words means more tokens, those little pieces of text the AI chews on, and that gets really expensive really fast. But here's the kicker. What if we've been looking at it all wrong? That's the crazy idea behind this DeepSeek-OCR paper. I mean, what if, instead of drowning an AI in thousands and thousands of text tokens, you could just show it a picture of all that text? And what if that picture gave you the same results, or maybe even better ones? So what we're really talking about here is a whole new way to think about compression. This isn't just your standard OCR, where an AI reads text from an image. No, this is about using the image itself as a super, super compressed package of information. And when I say super compressed, I mean it. The efficiency jump here is just wild. Think about it. Normally, 10,000 words would break down into something like 15,000 text tokens for an AI to process. But with this new visual method, those same 10,000 words become just 1,500 times vision tokens. That's a 10 times improvement. It's a huge deal. The fancy term the researchers came up with is context optical compression. But honestly, the idea behind it is so elegant. You just take a bunch of text, render it as an image, and let a vision language model do its thing. It works because, well, our vision models are already pros at squishing down massive amounts of visual data into something manageable. And let me tell you, people in the community caught on to this fast. This one comment from an online discussion really nails the feeling. This isn't just a small step forward. It's a completely different way of thinking about how we give AI information. Okay, so that's the big idea. But how in the world does it actually work? Let's peel back the layers and take a peek inside the DeepSeek-OCR model to see what's making all this happen. All right, so there's always a trade-off, right? You compress something, you usually lose some quality, but check this out. The data from the paper is pretty incredible. Even when they're compressing text by a factor of 10. 10! The model can still reconstruct it with 97% precision. That is an insane efficiency boost for a barely noticeable loss in accuracy. And even when you push it to almost 20x compression, it's still holding on to 60% of the info. That's just, wow. The secret sauce is this thing called the DeepEncoder. It basically works in 3 steps. First, it perceives. It looks at all the tiny details, kind of like how an AI can spot every single object in a busy photograph. Then, step 2, it compresses. A special layer just squishes all that visual data way, way down. That's where the token count plummets. And finally, step 3, it understands. Another part of the AI comes in to get the big picture meaning from that compressed data. And when you put it up against the competition, it's not even a fair fight. You got some models out there that need almost 7,000 vision tokens just to get through a single page of text. DeepSeek-OCR, it's sitting over here using less than 800. It's not just a little bit better, it's playing a completely different game. The efficiency is just off the charts. So a powerful model is great on paper, but can you actually get it to work in the real world? Well, that's exactly what developer Simon Willison set out to do. His story is a great example of putting this tech through its paces. And right out of the gate, he hits a wall. A classic developer nightmare, really. His brand new, top-of-the-line hardware was too new for the software he needed to run. You know the error message. It's the kind of thing that usually means your project is dead in the water. But here's where it gets interesting. Instead of spending hours pulling his hair out, he tried something different. He just handed the problem over to an AI. He gave a coding agent access to his machine and basically said, "Hey, you fix this." And you know what? It worked. The agent just went to work, started digging through different software versions, found one that was compatible, and installed it. Let that sink in for a second. An AI agent fixed the computer so that he could run another AI? That's pretty wild. The whole thing was done in less than 40 minutes, with the AI doing almost all the heavy lifting. So yeah, this isn't just some theoretical lab experiment. It proves that this model is practical, that you can actually get it up and running on real machines right now. And a story like that really gets you thinking about the bigger picture, doesn't it? What does this kind of 10x compression really unlock for the future of AI? The possibilities are kind of mind-bending. Okay, so right now, our best AI models top out around a 1 million token context window, which is already pretty big. But if you apply a 10x compression technique like this one, suddenly you're talking about a 10 million token context window. That's not just an upgrade.
That's a whole new paradigm. So, what does that even mean? What could you do with a memory that big? Well, you could literally cram an entire company's internal documentation into the AI's short term memory. You could feed it a whole software code base all at once. The AI could start to think like a real human expert with all the necessary info right there, ready to go. No need to constantly look things up.
But honestly, the deepest, most profound idea in this whole paper might be something else entirely. What if we could simulate human memory? The idea is you could take older text, older memories, and render them as blurrier, lower resolution images. So the stuff that just happened is crystal clear, but things from a year ago are fuzzy and faded, just like our own memories. And that just leaves you with this one big, fascinating question. We've poured all this energy into trying to give AI a perfect, flawless, infinite memory. But maybe, just maybe, the next giant leap forward will happen when we finally teach it how to forget.